which is how the third topic is how can I balance the chemical equations using the redox reactions. So balance the equations using redox reactions. These are all supposed to be old material. The new material will be actually in the relationship between these electrochemical cells and if the reactions are spontaneous or not, electrochemistry and spontaneity. And we'll see if the reactions are spontaneous or not according to the delta G. يمكن احنا خدنا الايكويشن بتاعتها بسرعه المره اللي فاتت but just to have a look about it. طيب so if we are talking about this one, the redox reactions, we know what is oxidation and what's reduction. It will be very silly to talk about it, but just we know that the redox is made from two half reactions. The first one is reduction, where the electrons are gained, and the second one is oxidation, where the electrons are lost, and the substance that is being reduced is what we call the oxidizing agent. So it oxidizes the other substance which is oxidized, and we call it the reducing agent. Okay, the general rules of the oxidation states احنا عارفين. we'll just mention them all fast. ان اي element الاوكسيديشن state بتاعته بتكون زيرو. اي ion الاوكسيديشن state بتاعته هي بتكون نفسها التشارج. So if I have Na plus, then the charge is +1. If I have NO3 minus, so the charge is -1, and so on. The fluorine is the element that never changes its oxidation state. It's all the time -1. The hydrogen is +1 if it is with the non-metals. So if you have a hydrogen with a non-metal, it will be +1. If you have a hydrogen plus metal, so it will be -1. The only case that the oxidation state of hydrogen is negative when it is in a hydride. A metal hydride is a compound made from the hydrogen and metal together, in which case the hydrogen will be finally -1, not +1. So it will be -1, not +1, what it is. Okay, so another is the oxygen. Oxygen, I know that 99% it is -2. Very rarely it is peroxide and superoxide. It will be -1. Like for example, if it is with hydrogen, in the hydrogen peroxide, it will be H2O2. It will be -1. It will not be +1. It will not be -2. The only case that it is +1 if it is fluorine, with fluorine, because we just said that the fluorine is always -1. So even if the oxygen is with the fluorine, then the oxygen is going to be +1. Aluminum and group 3 will be +3. Group 1 will be +1, and group 2 will be +2. أي compound, the total charge for the compound is, the total oxidation state of a compound is 0. أنا عارف دايما إن في بعض الحاجات زي السلفر، زي الكلورين، زي الفوسفورس، زي النيتروجين. I usually keep them at the end. So I usually don't try to start finding the oxidation state of them by starting with them. I usually start with the things that I know and then keep this until the end, because they have very variable oxidation states that changes a lot. يعني الكلورين مثلا عنده oxidation state كتير جدا جدا جدا. السلفر، الفوسفورس، النيتروجين the same. So I don't usually do them at the beginning. I usually do them at the end. طيب البالانسنج redox equations. البالانسنج using redox equations. So in this case, I know that the first step in أنا بقسم, I will divide the reaction into two parts. The first part is the half reaction, which is the oxidation half reaction. So oxidation half reaction and the reduction half reaction. And then I will start checking in every half reaction of them, is the atoms are balanced or not. أقصد إيه بالatoms? What do I mean by atoms? It means the atoms of anything which is, it means the atom of anything which is not hydrogen and not oxygen. So all atoms balanced or not. So if I have chromium here and chromium here, and for example, this is 2 and this is 1, so I will put 2 here so that they will be balanced. The second thing to balance is what? The oxygen atoms. How do you balance the oxygen atoms? Like if, for example, in this left you have one oxygen, but here you don't have oxygen. So I will add oxygen. I have to add oxygen here. How do you add oxygen? By adding what? By adding water molecules. So by adding water molecules. So if the left side has an oxygen and the right side does not have, so I have to add oxygen by adding water. So for every oxygen I need to balance, I will add one water molecule. Now what if I have 3 oxygens here and no oxygen here? So I have to add 3 water molecules and so on. Okay, so now you have balanced the oxygen, but you have disrupted the hydrogen, right? Because when you added oxygen through water molecules, the hydrogen now is imbalance. So I will add the hydrogen. So balance the hydrogen by adding what? By adding protons. Hydrogen by adding protons. So for example, I have added 3 water molecules here, and there is oxygen here balanced, but I need to add hydrogen here, so I will add 6 protons. So if you have added 6 protons, means you have balanced the hydrogen atoms here on the right side. The last thing to do is to balance the charges. How do you balance the charges? By adding what? By adding electrons. So in this part, there is, for example, now 6 hydrogens, so 6 positive charge, and here has 0 charge. So you need to add electrons on the left side. How many electrons I will add? I will add 6 electrons. So now there is 6 here and 6 here, so the total is 0. That's a balance. Then after that, I will just add the 2 half fractions. Add the 2 half fractions. Mister, when I add the 2 half fractions, I will notice that the number of electrons is not the same. So you have to first, before finishing the equation, you have to make the number of electrons the same on both sides. Make number of electrons. So make the number of electrons balanced. Where is the number of electrons? So make electrons count balanced. Like if you have 2 electrons here and here I have 5 electrons. So I have to multiply this equation by 2 and multiply this equation by 5. So now we will have 10 electrons and then here 10 electrons. And then don't forget to cancel out the electrons. If the number of electrons becomes the same, you should cancel it out. Why? Because there is a rule that tells me that in the redox reactions, there should be no electrons showing because they should cancel out. Well, let's see some questions about the parts that we have seen. Sample question 4 and 5, for example. Let me have a look. That is number. Let's have a look. I think there is no questions on the balance. They just go to the right parts. Okay, let me just have a look. Maybe we can get one later, no worries. Okay, so let me see the other part. This is still writing or no? Okay, so the next part is the 2 main reactions. احنا قلنا, we said that there is electrochemical cell or electrolytic cell and electrochemical cell, right? Just try to summarize very fast what is the difference between them. In the first one, I'm creating, this is electricity, or I am using electricity. In the first one, I'm using the chemical energy. So I'm using the chemical energy or the electric energy in the battery, and I'm changing it into chemical reaction like decomposition of the ionic compound. And here the opposite is happening. So I'm using the chemical energy, I'm using the chemical reactions that's happening to change it into electric current. So I'm producing electric current or electric energy from it. So basically here I have a battery that's connected to 2 electrodes, usually made from inert substance, and then put in a container, and this container contains the electrolyte, which is the substance that I need to decompose or break it down. It can be in one of two cases. It can be either molten electrolyte or it can be aqueous electrolyte, because these are the two forms of the ionic compound that can conduct electricity. So whatever electrolyte you put here, aluminum oxide, sodium chloride, lead bromide, whatever you want to put, you can put, and it will be broken down. So what do I name the positive part and the negative part? The positive electrode, I will call it the anode, and the negative electrode, I call it the cathode. Once you put the electric current, the ions becomes to form and they become charged, so they move towards the opposite charge. So the positive ions will go towards the cathode, so all the cations are going to move towards the cathode. Like for example, if you have H plus, it will move towards the cathode. So that it will take electrons and form H2. So here I have a reduction at the cathode. On the opposite side, at the anode, the oxidation happens. So if you have OH minus or you have Cl minus, the Cl minus will go here and it will lose electrons. So 2Cl minus will lose 2 electrons to form Cl2. So this is oxidation happens at the positive electrode, which is the anode. What did you do here? What is the benefit of this cell? You have broken down the ionic compound or the electrolyte, because it might be non-ionic, like HCl, for example. It's broken down into 2 ions. I can use it in extraction, for example. I can use it in extraction of aluminum or any other substance that I want to extract. The other side or the other cell, I don't put electricity. Actually, I get out electricity. So I can put a lamp or I can put a voltmeter, because these two will help me know if there is electric current produced or no. This time the electrode is not an inert electrode. It's made from a metal, and this metal is placed in a container. The container contains salt of the same metal. What is its concentration? In order to have standard conditions, the temperature will be standard, the pressure will be standard, and the concentration will be 1 molar concentration. So I have 1 molar of the concentration of this one and 1 molar of this one. 1 mole also per decimeter cube, which is molar of this metal. So for example, if I have zinc and silver, these two will be placed in a solution of zinc nitrate, for example, 1 molar, and this is silver nitrate, 1 molar. It should be soluble solution for sure. Okay, then what happens here? This is the electrode which is more reactive, so it will be oxidized. It will be oxidized. So the oxidation happens here, and this time this is the negative electrode, but it is still called anode. So this does not change. Take care, this does not change. This is called the anode, and this is called the anode here. The oxidation happens here, and the oxidation happens here. The only difference is that this is the positive electrode, but here this is the negative electrode. So it's called, here is called, the negative is called the anode. Here the positive is called the anode. So this is the positive, is called the anode. The cathode is the negative here, but here the cathode is the positive.
Yeah.
Okay, so cathode, here the reduction happens. Why? Because once I lose electrons with the more reactive element, this is the zinc is more active than the silver, so the electrons start to move, and they will go in the wire until they reach to the silver. So what is the movement of electrons? The electrons move from the negative to the positive in the wire. From the negative to the positive, from the anode to the cathode. And then the current has to be moving in through the cell, so I have to close the cell here. The cell is closed by a salt bridge. So if I'm asked what direction the electrons move inside the salt bridge, I know it inside the cell, it moves from the positive to the negative, to the opposite. It moves from here to here. Actually, there are 2 benefits that I have from the salt bridge. The first thing is that it closes the cell. The cell has to be closed in order to the current move inside it. So it closes the cell. The second benefit, it prevents accumulation of charges, So my potential difference comes from is that I have a difference in the potentiality here. So if the electrons keep coming from here to here, from here to here, then there will be a lot of negative charge here. And then there will be imbalance in the charge. This will be negative, this positive, the current will stop. So I have something to remove the ions. So I place some sodium nitrate inside the salt bridge here. What will the sodium nitrate do? When the sodium nitrate is there in the salt bridge, there is a sodium nitrate. The nitrate ions are going to move from here to here, from the cathode to the anode. What happens when the NO3 moves from the cathode to the anode? It takes some of the negative charge because the negative charge was piling up here from the electrons. So it takes the negative charge from here to here, and this helps to restore balance to the charges, restore charge balance. I will not have accumulation of negative now. Why? Because nitrate has moved here and took some of the charges from the right to the left, from the cathode to the anode. So this is the benefits of the salt bridge. This is what we call the standard conditions, here. I know that there is one cell will be oxidized and one cell will be reduced. So I can just find the total EMF, or what we know as the E node cell, which is the total EMF. This is the voltage that will show as volt on the voltmeter. And if I want to calculate this manually, then I'll have to go to the table. The table is called what? That he will give me in the exam is called the reduction potentials, right? The table that contain the reduction potentials. It is a long list of reduction potentials for all elements and substances, but I will notice that there is always a reduction. There is never an oxidation here. And I will see that the elements go to become more reactive as I go down. So the very reactive metals, for example, the sodium and the potassium and the lithium and the aluminum and like that are at the bottom, but the less reactive substances are at the top. The less reactive ones are at the top. I will see that the value here is more positive values, while here will be more negative values. So if you are given two elements and you were asked which one will be the anode and which one will be the cathode, you just have to go and look at your reduction potential and see which one is more negative, because the one which is more negative will be the one that is oxidized. So let's have a look at it. This is the table, the reduction potential. So if I look here, I will see that all of the reactions are reductions. The table is called the reduction potentials. It's not called oxidation potentials or not called the mix. It's only called what? Reduction potentials. Then I will see the elements at the top here are the least reactive elements, but the ones at the bottom here are the highest reactive. And I will see that the number here is what? The number here is more negative number, right? You can see the screen, right? The table. So it's more negative elements like the lithium. This is more reactive and more negative. So for example, if I am given lithium together with what? If I am giving lithium together with copper, so I know the lithium is the one that is more reactive. What will happen to it is this the one that has to be oxidized. And here, this is the one that has to be reduced. Okay, so the one that's oxidized and the one that's reduced. So I'll have just to get the two values and put them side to side and have a look. So I'll have to get the two values, put them side to side. Mister, you said that there are two values here and two substances that will react together to form the cell. So how do they get together? We can get the values here. The first value is the value for copper. We said that the copper takes one electron, copper 2 takes one electron, and it forms copper plus, and the value for that one is 0.15. And then the lithium takes one electron and forms lithium, and the value of that is 3.015. We said that the one which is more negative is the more reactive one, and the one which is positive is the less reactive one. So if we put this together, one of them will be oxidized and one of them will be reduced. But what is the value of 0.15? What is the value of negative 3.05? How did I get this value? How did I know that copper alone is plus 0.15 and lithium alone is 3.015, 3.05 by negative? How did I know these values? In order to know these values, I put them together in front of a zero substance. So when I put it against a zero substance, so substance is zero, and the value for this, for the lithium, is one. I want to find it out. So what is the number, the reading that I found in the voltmeter? Negative 3.05. But how did you know that this value is for the lithium alone? How did you know that this is for the lithium alone? 3 point, because the substance in front of it is what? Is zero. So what is this substance that is zero? What do we call it? We call it the standard hydrogen electrode. So the electrode which is made from only hydrogen, the standard hydrogen electrode, what is its value? Its value is what? Zero. Electrode, the value of it is equal to zero. So if you put it against any substance and a number shows, then the number is for what? Is for this substance. If I get negative 3.05, so what is this value for? It is for lithium. Okay, I need to do something else, like I will put the standard hydrogen electrode and put it against a different substance. That I need to find its value also. For example, I delete this one and see the value of another substance. Like I've changed my mind, I want to get the value of potassium instead. So I will put potassium here. I know that potassium plus electron give me K, and I need to find this value. So I will put the potassium together with the other element. What is the other element that I will always choose? The hydrogen. Why? Because it is zero. What will be the number that shows here? I need to find out potassium. I will see negative 2.92 at the voltmeter. So what is the value of potassium? Negative 2.92, because this is zero and the total is negative. So this is for potassium is negative 2.92. This is how I found the value of every element separate. Okay. So now, Mr., you have the two values. You have copper and lithium. You said one of them has to be oxidized. Which one has to be oxidized? The more reactive one will be oxidized, the one which has more negative electrode potential, or E cell, the one that has more negative E cell. So I see that the lithium is more negative. So this one will be oxidized. But Mr., what you will do, يعني? I have noted that in the reactions that I wrote, both of them was reduced, but actually I need one of them to be oxidized. So I will reverse the copper. I will reverse the copper. What you will do with the copper, Mr., I will reverse it. And instead of being copper plus one electron, I will make it, oh, here there should be no charge. So there should be no charge here. So copper will give me copper 2 plus and 1 electron. Oh, it is correct. Yeah, because 1 electron only. Sorry. Actually, I was correct. Yeah. It is plus 1 because only 1 electron is gained. So copper plus 1, give me copper 2 plus and 1 electron. Okay, what is the value of this one, yeah, Mister? It will be negative 0.15. So it will be negative 0.15. What if I put this with the lithium? The lithium will be as it is. Why you make it as it is? Because it is reduced. How did you know that this is reduced? You kept it as a reduction potential. Take care of what I'm doing now. So this will be oxidized and this will be reduced. Mister, when you add the two values, what value you will get? You will get a negative. Oh, Mister, what if I'm insisting that this is 1.5? It is only 5. So when you add these two values, what do you get? You get 2 and 3. Mister, this is a negative value. I know the rule from last year that if this is negative, it's not working. So the cell is not working. It will not give a value. How you will know it will not give a value? There will be no current. There will be no potential difference. So there will be no potential difference. Why there is no potential difference? Why it's not working? Mister, because I intentionally made a mistake. What is the mistake? I said that the more reactive should be the one that's oxidized, but you didn't choose the more reactive, you choose the less reactive, right? You didn't choose the more reactive, you choose the less reactive. Which one is the more reactive that you should have used? I should have used the lithium because the lithium is more negative. This is the E cell, so I should have oxidized this one. So this one that I did was wrong. So I should not do it like that. I should not do it like that. So this is wrong. I should have made the oxidation for the lithium. So when the lithium oxidizes, it is reversed. So the lithium will give me Li plus electron, and it will be positive 3.05. Now the other one is the one that's going to be reduced. So I have to reverse the copper, not the. So I have to keep the copper as it is because it is reduced. And in the table already it is what? These tables, they are all reduced, all reduction. So I will keep it as it is. You want to be reduced. This is oxidation and this is reduction. So keep it as it is. It will be 0.15. So 0.15 plus. So copper 2 plus 1 electron give me copper plus. Now when I add these two values together, what do I get? Is it oxidation or reduction? One of them oxidation, one reduction. So when I make the addition together, I will get a positive value. So I will get a positive value means that it's going to work. So 3.20, this is going to work. And it will be called spontaneous. Do you remember when we said it is spontaneous? Means that the reaction is going to happen. This is the same word that we used to use last year. And we say that is the cell spontaneous cell or non-spontaneous cell. What is the meaning of spontaneous? Spontaneous means it happens at its own. So at its own, the reaction is going to make a current without me intervening. You just put the lithium here and the copper plus 1 here, then you put the voltmeter. You don't do anything else. The lithium in its solution, copper in its solution, salt bridge, you will find the potential difference. What was the potential difference that we found? Negative, it will be positive 3.20. So you will get a value of positive 320 here, automatically happening. This is a spontaneous cell. Okay. Until now, we did not take anything new, but can we link this to the new year information? What is the delta G here? Is it going to be a positive delta G or a negative delta G? Mister, this
If
is a
it's spontaneous, it's negative.
very good. So it is a spontaneous reaction. So it is a negative spontaneous reaction means negative Gibbs energy value. If it is like the previous one and it's not spontaneous, when we made the oxidation to the copper by mistake, then it's going to be a positive delta G. So the delta G will be a positive delta G. This is the one that failed. So delta G here is going to be positive. So a working voltaic cell should be having a negative delta G, which means that the reaction is spontaneous. It didn't happen. What about the electrolytic cell? Mister, the electrolytic cell, the delta G is always what? Is always positive. Why, Mister? Because this reaction is not going to happen unless I put the battery. So unless I put the battery and make it work, it's not going to happen by itself. Okay, let's see what else we have here. Yeah, we didn't forget. I think we forget to say only the electrons move from where to where, from the anode to cathode, but we just forget to write the current moves in the opposite. So the current moves in the wire from the cathode to the anode. This is exactly the opposite of the electrons. So this is the opposite of the electrons. Of course, in the wire. So, Mr., this means that in order to find out what is E node, so in order to find out what is E node, let me just put this on the right here. Okay. So in the summary of the reactions that we have said, we said that the E node of the cell, which is the total electromotive force we are getting, E node from the cell, as a summary is equal to the E node of the reduction that's happening plus the E node of the oxidation by adding them together like what we did. But don't forget to reverse the oxidation one. So for example, we found that the lithium is the oxidation, so we have to reverse it and make it oxidation, then its sign will be reversed, then I can add it to the reduction one. Okay. Then there is the last equation that we took from the last time. I'm not sure actually if we have taken an example about it or no. That's why we will say that the delta G, or the Gibbs free energy, is equal to minus NFE cell. So what is minus NFE cell? The N is the number of electrons. So this is the N, the number of electrons, and F is the Faraday's constant. And then I have an FE cell, and E is the potential difference that's happening. So this is the delta G if there is no standard conditions, and if there is standard conditions, delta G node is equal to minus N FE node cell at standard conditions also. Okay, let me just pause.